Today we're going to do sections 8.1 and 8.2 in your book. We're going to start with something called geometric mean. When you have a geometric mean, you can make a proportion like this with a over x equals x over b. X is the geometric mean between a and b. If you think about the word average, if I asked you to find the average of three numbers, you would know to add those numbers and divide by 3. So the word average tells you what mathematical operation to perform on those numbers. Geometric mean is the same way. When you want the geometric mean of two numbers, or if I were to solve this proportion, I would multiply both sides together and get x squared equals ab. So the geometric mean is the square root of the product of those two numbers. For example, if I have the two numbers 9 and 4, I multiply them together to get 36 and take the square root to get 6. So 6 is the geometric mean between 9 and 4. I would like you to know how to find geometric mean both by doing this operation and by setting up and solving this proportion. The proportion is going to be extremely important in the activity that you're going to do next. In this activity, we're going to look at geometric mean geometrically, or with triangles. Alright, now we're going to talk about the Pythagorean theorem. We talked about the Pythagorean theorem a little bit when we looked at the distance formula in Chapter 3. Remember, the Pythagorean theorem only works for right triangles. So notice the parts of right triangles, legs and hypotenuse, are in the wording of the Pythagorean theorem. The Pythagorean theorem says that the sum of the squares of the lengths of the legs, A and B, is equal to the square of the length of the hypotenuse, C. It's important to understand that the letters A, B, and C are not necessarily what those letters will always be. So A squared plus B squared equals C squared is an easy way to remember the Pythagorean theorem as long as you remember that in that equation A and B are the lengths of the legs and C is the hypotenuse. If other letters were used to represent those lengths, the lengths of the legs would be here and here in the equation, and the length of the hypotenuse would be here. A Pythagorean triple is a special type of set of numbers that work in the Pythagorean theorem. If you have a Pythagorean triple, they must be whole numbers, and the two smaller numbers would go in for A and B. The largest number would go in for C in this equation. Remember, Pythagorean triples have to meet both conditions, work in the equation A squared plus B squared equals C squared, and be whole numbers. These are some common Pythagorean triples that you will see throughout this chapter. Alright, now I have another activity for you. I have some numbers A and B that represent two sides of a triangle. C will always represent the biggest side of the triangle. So that's important to remember when you are filling out this chart. Also, don't forget that the sum of two sides of a triangle must always be bigger than the third side. So when you're making a range for possible lengths for side C, keep those ideas in mind. What I want you to do is solve these equations or inequalities. If A squared plus B squared equals C squared, there will only be one value for C. If we have an inequality, then we'll have a range of values for C, and you should write an inequality here. Then I want you to think about what type of triangle you would have. If a squared plus b squared equals c squared, if it's less than c squared, or if it's greater than c squared, and mark that in this column.